Okay, just want to make a video of me doing some derivatives. Hopefully that'll spur you to practice because you can attempt these and then try them, check to see if you got them right. So actually I think a good way to do this would be to use this worksheet, maybe print off a new copy of it from the Canvas page, and start the video, pause it, do the first two, then maybe watch the video, and just kind of, this would be a good way to kind of check yourself and get some immediate feedback. Okay, so here we go. So this is a, number one, we've got a something times something. In this case, it's a fairly simple multiplication of the distributive property. So I would probably just do that. So before I take the derivative, I'd rewrite this as f of x equals, let me blow this up a little bit. F of x equals x cubed plus x to the, now this is x to the 6 halves, and that's x to 1/2, so it'd be x to 7 halves. That's just some algebra. Then when I go to take the derivative, it's now just a couple of power rules. So that'd be 3x squared. That would be 7 halves x to the 5 halves. Okay, this one on the other hand is something times something. Well, we could multiply it out also. So this would be t cubed times that. Notice, think of this as 2t to the negative 1. So t cubed times that would be 2t squared. And then 2 over t times 1 would just be, and I'm going to write it like that, 2t to the negative 1. Then multiply t to the 5th times t cubed. That would be t to the, 8th? And t to the 5th times 1, that would just be t to the 5th. So yeah, that's not a bad multiply through. So again, now we could take the derivative of that, so that'd be g prime of t. That would be 4t minus 2t to the negative 2 plus 8t to the 7th plus 5t to the 4th. Just a bunch of power rules there. And that's number 2. So now if you want to pause the video and try 3 and 4, and then come back on and start the video when you're ready. So first thing I do in this one is I would rewrite it as y cubed plus 2y plus 1 whole thing raised to the negative 1 power. That way I can use the power rule and a chain rule. So the outside function here is something to the negative 1. So when I take the derivative of that, I get negative 1 times the something to the negative 2. And the something is y cubed plus 2y plus 1. And then I need to multiply that on the outside by the derivative of that something. So the derivative of this inside would be 3y squared plus 2. And just to make things clean, I would probably multiply the negative through there. So I'd have a negative 3y squared minus 2 times, oops, it's a funny looking 3, times the rest of this stuff. And this one would be done in a similar way. I'd rewrite this as x plus x to the 1/2 to the negative 1. And then when I take the derivative, I don't like that. I'll use the good notation, dy dx. That would be negative 1 times x plus x to the 1/2 to the negative 2. And then derivative of the inside would be 1 plus 1/2 times x to the negative 1/2. And again, I could probably distribute that through, so I would get negative 1 minus 1/2 x to the negative 1/2 times x plus x to the 1/2 to the negative 2. Okay, once again, I'd recommend you pause the video and go try number 5 and 6, and then come back when you're ready. And I'm going to keep going. So dy dx, In this case, I got to use the product rule, so I have a u and a v here. The u is, so the derivative of u would be ln 2 times 2 to the x, and the derivative of v would be just e to the x. So then here I want u v prime plus v u prime. So the u is 2 to the x times v prime is e to the x. And then v is e to the x times u prime, which would be ln 2 times 2 to the x. Over here we got a product rule. We have a quotient rule. You could bring that bottom up to the top of the -1 power and use the product rule, but I'm going to go ahead and do the quotient rule since we haven't done one yet. So that would be g prime of z. Okay, so we have this is really, we're going to call this u over v. So my u prime would be 2z, and my v prime would be 3z squared. So I need a v u prime minus a u v prime all over v squared. So now I just got to fill in the spots. So v is z cubed minus 5, and u prime is 2z, and then u is z squared plus 1, and then v prime is 3z squared all over v squared, which is z cubed minus 5 squared. Now this will require you to do a little bit of algebra to simplify this. So if I multiply 2z through, I get 2z to the 4th minus 10z minus 3z to the 4th minus 3z squared. Still all over that z cubed minus 5 squared. And we can combine some like terms on top. So 2z to the 4th minus 3z to the 4th, that'd be negative z to the 4th, and minus 3z squared minus 10z. And all that is still over z to the 3rd minus 5 squared. Okay, I'm beginning to sound like a broken record, but again, you would pause it, try your hand at 7 and 8, and then come back and check yourself. So here, I'm going to use the quotient rule again. So that would be dy dx. So it would be low x cubed plus 1 times the derivative of the high, which would be 1/2 x to the negative 1/2 minus the square root of x. And they're going to be, you know what, actually before I do the quotient, I'm going to multiply those out. That's not a bad multiplication. So z is equal to t squared over, that'd be 2t minus 8 minus t to the 4th plus 4t cubed. Sorry, my brain wasn't working very fast there. Okay, so now I can take dz, dt is really what I'm doing here. So that would be, those can't combine at all. So that didn't really help me that much, but multiply that out. I'm going to rearrange it so it's 4t, nope, that would be negative t to the 4th plus 4t cubed plus 2t minus 8, all times 2t minus t squared times, so the derivative of that thing I just put up there would be negative 4t cubed plus 12t squared plus 2. All of that is over this same thing up here, negative t to the fourth plus 4t cubed plus 2t minus 8 squared. Of course, we could clean this up a fair amount. So dz dt is equal to, let's see, if I multiply the 2t through, I get negative 2t to the fifth plus 8t to the fourth plus 4t squared minus 16t. And over here, I'm going to get a plus plus 4t to the fifth minus 12t to the fourth. I'm just distributing this thing now. Plus, nope, minus also. Minus 2t squared. All of that is over my negative t to the fourth plus my 4t cubed plus 2t minus 8 squared. And last, finally, we just combine some things. So negative 2 and t to the fifth and 4t to the fifth, that would leave me with a positive 2t to the fifth. And 8t to the fourth and negative 12t to the fourth, that'd be negative 4t to the fourth. And then I got a 4t squared and a negative 2t squared. That'd be a positive 2t squared. And then take it on, and then it'd just be a minus 16t. And all that is still over negative t to the fourth plus 4t cubed plus 2t minus 8, whole thing squared. Okay, I'm going to simplify this a little bit first. That would give me if I multiply that x squared of x through, that would give me x to the 5 halves plus x to the 1 half divided by x squared. And then actually we can divide x squared in each one of those. And so we get, that would be x to the 1 half. This is 5 halves minus 4 halves. And that would be plus x to the negative 3 halves. And now I'm ready to take the derivative. So h prime of x would be equal to 1 half x, whoops, daisy, 1 half x minus 3 halves x to the, come on dude, to the negative 5 halves. And that's it. That's pretty slick. So this looks like a product rule within a quotient rule. So I'm going to do a little u-v thing here. So u prime is going to involve the product rule. Do you see that? U prime is going to be e to the m times m to the 1/3 plus e to the m times 1/3 m to the negative 2/3. And v prime, of course, is just going to be 2m. That's nice. So I'm looking for y prime of m. that's going to be u prime v minus v prime u all over v squared. So I'm just plugging into that. So u prime would be e to the m times m to the 1/3 times v, which would be m squared plus 3, minus e to the m to the, whoops, I left off a big chunk there, didn't I? Okay, let me try that again. Let's try that again. Okay, so I'm going to do e to the m to the 1/3 plus e to the m times 1/3 m to the negative 2/3 times this whole thing is multiplied by v, so that would be m squared plus 3. Okay, just to make it clear, all this stuff, that whole place in the parentheses was just the u prime. So this is the v. Now I'm going to subtract, and I'm going to bring it on to the v prime, which is just 2m. And then I need a u, which is e to the m times m to the 1/3. So actually I could combine those, couldn't I? M to the 1/3 times m would be m to the 4/3. So we'll just do that. M to the 4/3 e to the m. And all that is over m squared plus 3 squared. We could simplify this a little bit. So let's see, m squared times that is going to be e to the m times m, that's 6/3, so that'd be 7/3, plus m squared times this mess would be 1/3 m to the, let's see, 4/3, because you're doing 6/3 minus 2/3. Times e to the m, then multiply 3 times that would be plus 3 e to the m to the 1/3, and 3 times this would be, the 3 and the 1/3 cancel out, so I'd just have e to the m to the negative 2/3, and we still have that little bit at the end there, minus 2m to the 4/3 e to the m. All that is over m squared plus 3 squared. Now, do we have any like terms? Yes, we do. We have this guy and this guy are like terms. Look at that. So I'm going to have e to the m to the 7/3, and those guys are going to combine to give me negative, let's see, that's 6/3 minus 1, so that'd be negative 5/3 m to the 4/3 e to the m plus 3 e to the m to the 1/3 plus e to the m to the negative 2/3. Whole thing over, m squared plus 3 squared. Okay, so there's more of the worksheet left, but I think this video is getting a little bit long, so I'm going to end the video, and then maybe I'll pick this up later on another video. All right.